All right, today we have a video on function operations. So you are allowed to do math with function rules. What does that look like? Well, a lot like combining like terms. So when you have something like this, you have two functions using their rules. We use function notation for this, g of x and f of x. Remember here, g and f are the name of the function. Of x tells you the independent variable, and then we have our rule. This means add g and f together and continue using variable x. You could also say that this is g of x plus f of x. That's another way to do it. So you're going to have this. So you have g of x is x plus 2. F of x is negative 2x to the third minus 2x squared. And we are being asked to add them. Well, this one is actually pretty easy because that's your answer. Notice that there's no like terms here. So all I have to do is take and put it in standard form. So negative 2x to the third would be first. Negative 2x squared, remember the powers go in order, would be second. Positive x would be third, and plus 2 is last. And that is g plus f of x. Right? Let's take a look at another one. This one, g and f of t, though, so they've changed the independent variable, but we still have our functions g and f. They would like us to add them. Okay, add f. Well, f is t minus 2 plus g. G is t squared plus 5. Okay, now I do have like terms, so t squared would be first. Actually, let me keep the colors I chose. And then t would be next, positive t. But I have like terms with negative 2 and positive 5. I have to put those together to be positive 3. And that is f of t, as I'm so used to writing x, plus g of t. All right? Just combine like terms. 4 is subtraction. So we're going to subtract f minus g. So I'm going to do this old school like in first grade. I'm going to put it vertically. F of n equals n squared plus 3. Subtracting g of n equals 3n minus 2. I'm going to move this plus 3 over, and I'm going to explain why in a second. So my result is going to be called f minus g of variable n, and we'll do it. Okay, the reason I arranged it kind of weird looking like that, there's no n squared in g, so there's nothing to subtract from the n squared. It's part of my answer. There is nothing n in f, so I'm doing basically 0 minus 3n, so that's a negative 3n in my answer. And then I have 3 minus negative 2 is really 3 plus 2, so it's n squared minus 3n plus 5. Could you have done it all in one line? Sure. Could you have done it using mental math? Sure. I will tell you, though, we always make more mistakes with subtraction when we have it all in one line or mentally, especially with this. Multiple terms, positive and negative signs floating everywhere. All right. You guys take a second and try this one. Hit play when you've got an answer. And the answer here is f minus g of n equals n squared minus 6n plus 1. I lined it up just like I showed you in the last one. N squared minus nothing is n squared. Negative 2n minus 4n is negative 6n. Nothing minus 1 is minus 1. All right, we can also multiply functions. So f of t times g of t is going to be equal to, and we're going to write it like FOIL, negative 3t to the third plus 5 times t minus 5. and then FOIL it. Negative 3t to the third times t is negative 3t to the fourth. Negative 3t to the third times negative 5 is positive 15t to the third. 5 times t is 5t. And then 5 times negative 5 is negative 25. No like terms, that's my answer. All right? And pretty much that's what you're doing, different versions of that the whole time. You might have binomial times trinomial. You might have, if they want to be really mean to you, trinomial times trinomial. But a lot of times it would be simple distributive property or FOIL. Division. Okay. Division can be unpleasant. Division can be one of those things that they're very nice to you and ask you for a very simple step, or they're not. All right, so I'll show you one of each. A nice one. G of n divided by h of n. Okay, well, we know division can also be made as a fraction. So g of n divided by h of n would be equal to negative n to the third minus 4n squared minus 2n over n minus 3. I should factor just to make sure there's nothing in common here. So I can pull an n out on the top. That would be negative n squared minus 4n minus 2. N squared minus 4n minus 2 is prime. There are no factors of 2 that give me 4. N minus 3 cannot be factored. Remember that I cannot cancel the two n's because n minus 3 is part of a subtraction expression. I'm done. They were nice to me. I really didn't even need to factor the top because there was no way to find a companion n minus 3 to cancel. All right? Factoring is a good habit to get into, though, because when you get to rational functions, you'll be doing it all the time. So if you get in that habit now, it's going to be very helpful. On the last problem, I'm going to show you one where they're not too nice. So g divided by f would be negative 2x to the third plus 6x divided by 3x. Why are they not nice to you here? Well, because there is a common factor. Okay. So I have to factor the top. They can both lose an x. I get negative 2x squared plus 6 inside parentheses. 3x is still there. And then I do have to cancel. So I would be left with negative 2x squared plus 6 over 3. I can't cancel the 3 and the 6 because the 2x squared plus 6 is a addition expression. Now you might say, well, that wasn't too bad. You just had to cancel an x. Yes, that was this example. Sometimes it could be you have to factor two trinomials and cancel. To be honest, you won't see that too much in this part. You'll see it more when you get to rational functions. But you should be aware that it happens. So if you're being asked to divide functions, always be on the lookout for is there something that you need to cancel. All right. Thanks for watching the video on function operations.